Okay, so this is the standard that we are looking at right now, the different states of matter, and looking at properties of the three most common states of matter. And if you need additional help with this, if you go to Google Classroom, you open up Unit 17 of Study, this will show up. And if you don't, open up LO3, and you scroll up, you click on States of Matter under 3A. You will see the simulator, which is a good simulator. And then you can play around with it, and you should be able to see the information that I'll be sharing with you here. Additionally, if you look at LO3 notes, you have more information that you can look at to help you, again, fill out this chart on your own. So gas particles, solid particles, and liquid particles. So if you actually look here, you kind of have a visual to help you go ahead and fill in this information. As far as energy goes, the arrows here representing energy, and you see that gas particles have this 3C and 3A go hand in hand, and in chemistry, all the parts go together for so we can get the whole picture. So gas particles, they have a very high energy. So they have very high energy. They move very random and all over the place due to the fact that they have a lot of space between them. You can push them together. You can squeeze it. So you can squeeze it together, or you can compress it. Okay, very compressible. Density, very low, because the gas particles are very far from each other, so they're not really tightly packed. Organization, not really organized at all. And interparticle bond attraction, they don't have a lot of attraction. That's one of the reasons why they have the other properties. As far as solid particles go, we have this illustration. You can see that solid keep their shape even when you put them in a container, and they also keep their volume. They are fairly well organized. You can see some type of pattern going on here. They are so very low energy for solid particles. As far as movement goes, they vibrate. The particles will vibrate in place, and solid particles are so tightly packed that you really cannot push them any closer together, or you cannot really compress them. So solid particles are incompressible. As far as density goes, they're very tightly packed again, and density is how much can we pack something within a space, um, in this case. So you can't, the particles are already so tightly packed that you can't really pack any more in or compress it. So we say it has very high density. Organization, very well organized, tightly packed, keeps its shape, keeps its volume. When you put a solid in a container, it will still maintain its shape. It will not take the shape of that container. As far as interparticle bond strength slash attraction goes, it's very high attraction, and that's really one of the reasons why we can see the other properties here. Okay, liquid particles. Liquid particles are sort of moderate as far as energy goes. Movement, a little random, but they can't go wherever they like because they don't have that much energy. So what they do is liquid particles are close, but they have enough space where they can slide past each other and move that way. And they are almost incompressible, virtually incompressible, because the particles are close. As far as density goes, moderate amount of density, or how packed they are. Organization, not really well organized, but more than a gas, not as organized as a solid. Interparticle attraction or bond is moderate. If we look at gas particles, then we'd be able to answer question number three. But let's look at number two first. So for number two, since we looked at liquid last, why does water take up the bottom of the glass? It's really because um, liquids, okay, have a moderate amount of attraction. They have enough attraction where the particles can stay next to each other, but not too much where they're fixed and they cannot move or slide past each other. So they have enough attraction to stay together, um, and also be able to slide past each other. So when you pour a liquid of water in this glass, the attraction will keep the particles together. And then when they gravity will pull it down, and when it hits the bottom, the particles are really trying to accommodate themselves. And since there's enough room, they will slide and they will just take the shape of the container. Right? So water does that because it's a liquid and it has those properties of moving, sliding past each other, and also a moderate amount of attraction. Also, not too much energy where the particles would just go on escaping. On the other hand, why a gas is normally stored in high pressure cylinders and not in an open container like in erlenmeyer flasks? So why are gases stored in here and not here? Well, that is because gas particles have, again, this chart, very important, have very high energy. They move very randomly, very rapidly. So if you put them in an open container, due to the fact that they don't have a lot of traction, they're just going to escape or they're going to diffuse and you're going to lose your gas. But if you put them in a container like this, you can actually fit a lot more because those containers can handle high pressure, so you can compress the gases. You can push the particles together to a point where they are close enough to be a liquid, so you can fit more of them in here. So reason number one why we use high pressure cylinders to contain gases is because we can fit more of them because gas is very compressible. Reason number two, we would lose our gases if we don't do so because gases have very high energy. They move all over the place randomly, not enough attraction to keep them close together. So that is 3A, comparing and contrasting properties of three most common states of matter: solid, liquid, and gas, as far as their energy, movement, compressibility, density, organization, and bond strength goes for particle to particle attraction.